Okay, let's introduce the concept of what an acid is, what a base is, and acid-base reactions. Okay, acid is a substance that yields hydrogen ions in water. And another way of saying hydrogen ion, sometimes you'll hear that it yields a proton in water, because that's what a hydrogen ion is a proton. Okay? A lot of acids, they start with H, and we've already gone over naming acids. But that's not always the case, that they don't have to start with H. So realize that, not always. There are 7 acids that are classified as strong acids. And they are sulfuric acid, nitric acid, perchloric acid. Maybe you want to let me say it and you pause it and see if you can write the formula before you look at it on the slide, and just practice writing formulas for acids. Okay, after perchloric, there's chloric acid. And hopefully the next 3 will be very simple for you. Hydrochloric, hydrobromic, and hydriodic. Hydrochloric acid is HCl. Hydrobromic acid is HBr. And hydroiodic acid is HI. Now, these are the list of 7 strong acids. The fact that they're strong, what that means is that they completely ionize in solution. In other words, HI in solution, HI will completely ionize to make hydrogen ions and iodide ions. And they're in solution, they're in water, so we know that everything's going to get an AQ. HBr would completely ionize to make hydrogen ions and bromide ions. HCl would completely ionize to make hydrogen ions and chloride ions. Chloric acid would completely ionize to make hydrogen ions and chlorate ions. Don't break those polyatomic ions apart. Perchloric acid is going to completely ionize to yield hydrogen ions and perchlorate ions. And nitric acid is going to completely ionize to yield hydrogen ions and nitrate ions. And sulfuric acid, for now, we're going to write this in one step, and we're going to show that it ionizes to yield 2 hydrogens. See, because you've got to have it balanced. It's H2SO4 plus sulfate ions. Okay? And so that would be the complete ionization for any strong acid. See, they all fit the definition. Yields hydrogen ions in water. So let's look at what a base is. A base is a substance that yields hydroxide ions in water. And the strong bases are easy to remember because they're organized neatly on the periodic table. Any group 1 hydroxide is a strong base. Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, okay? Those elements of group 1. I'm just going to list these 3 here. And also your heavy group 2s. Your calcium hydroxide, strontium hydroxide, and barium hydroxide. These are all classified as strong bases. Strong means they completely ionize in solution. So they would completely break down to yield the hydroxide ions and then whatever that metal cation is. Now, that term strong acid can be a little misleading because that doesn't necessarily, or strong acid or strong base, it doesn't necessarily mean that they are more corrosive than others. Because there are some acids that are classified as weak acids that are just as corrosive. It's just they don't completely break down. When you have a weak acid, Instead of having this arrow going one direction, weak acids, that arrow goes both directions to show that it's not completely breaking down. Okay, but right now we are just looking at the strong stuff, strong acids and strong bases. And when I get down here to the calcium, strontium, and barium, I'm going to have the same thing like I had over here with the sulfuric acid. I'm going to have 2 hydroxides on those. Okay? And the barium would be likewise. And those are all AQs. So those are what an acid is, what a base is, and that's how the strong and the weak ones ionize. Okay, now we're going to look at a reaction, a certain type of reaction in which an acid and a base react. And we're going to stick with the strong acid and a strong base. This is known as a neutralization reaction. In a neutralization reaction, we're going to look at what happens when a strong acid combines with a strong base. In a strong acid and a strong base reaction, your products are always going to be a salt and water. Now, when I say salt, you think of sodium chloride, table salt. Now, in the first reaction, that's going to be the salt we make. HCl is a strong acid, and sodium hydroxide is a strong base. What would the products of this reaction be? Well, basically, guys, what you're doing is you take the cations. Remember, the cations are always written first. Cations are the positives. Take the sodium hydroxide, that sodium and the hydrogen, and exchange places. Put the sodium where the hydrogen is. So see, it's going to then be it's going to make NaCl, and put the hydrogen with the hydroxide, and that's going to make HOH, which is water, isn't it? So our products here are going to be table salt, which would dissolve in water, and water. And we need to balance that equation. So pause the video, take a second to balance it. And once you restart it, you will realize, hopefully, that it's already balanced. Okay, so a strong acid and a strong base always make a salt and water. Well, how is the salt going to be NaCl every time? No, only in this one. What if our strong acid was nitric acid and our strong base was potassium hydroxide? Can you write that reaction, nitric acid and potassium hydroxide? Same thing. The cations, the hydrogen and the potassium, swap places with them. Let them exchange places with each other. And this time, you'll have potassium nitrate, and you're still going to have water. Potassium nitrate is a salt. If you've ever heard of saltpeter is potassium nitrate. So how can that be a salt? In chemistry terms, a salt is a substance in which the cation comes from a base and the anion comes from an acid. So you can see, if you take any combination of those strong acids and strong bases, there's a variety of different salts you can make. In a strong acid, strong base reaction, your salt is always going to be your spectator ions. Okay? So these are always going to be your spectator ions. the sodiums and the chlorides in that first example, the potassiums and the nitrates in the next example. So anytime you have a strong acid and a strong base reaction, your net ionic equation will always look like this. Hydrogen ions plus hydroxide ions make water. That will always be the net ionic equation for a strong acid, strong base reaction.